Theoretical recap. A regular expression, regex, is a sequence of characters that defines a search pattern. In Python, the R module provides all the tools needed to apply these patterns to strings. The key functions to know are re.findall, which returns all non-overlapping matches as a list, re.search, which finds the first match, and re.compile, which precompiles a pattern for reuse, more efficient in loops. An IPv4 address follows the pattern, 4 groups of 1 to 3 digits separated by dots, for example 192.168.1.1. A naive regex like \d1, 3 \d1, 3 \d1, 3 \d1, 3 will match the structural format but may return false positives such as 999.999.999.999.999. A more robust approach adds boundary anchors or post-processing validation, checking each octet is between 0 and 255. Common mistakes beginners make: forgetting to escape the dot. In regex means any character, \, means a literal dot, not using raw strings, r, and getting confused by \, escaping, and returning duplicate IPs without deduplication. A quick mental model: think of regex as a stencil you slide over a text. Every time the stencil fits, you get a match. In the security context, extracting IPs from logs is a fundamental reconnaissance and incident response task. It is the first step before correlating events, detecting intrusions, or feeding data into a port scanner. Workshop brief. In this workshop, you will write a Python script that opens a log file, applies a regular expression to extract all IPv4 addresses present in it, deduplicates the results, and saves the unique addresses to an output file. This task directly consolidates your knowledge of the R module covered in the previous chapter and connects it to the file handling and exception management skills you practiced in earlier workshops. The ability to parse logs programmatically is a core competency for any security automation specialist and will be reused throughout the pen test and DevSecOps modules of this course. You are provided with, or must create yourself, a sample log file named sample.log. This file should contain realistic log lines mixing Apache access logs, SSH auth logs, firewall entries, and arbitrary text. It must include a variety of valid IPv4 addresses, some repeated, some appearing in different contexts, a few malformed addresses, for example 999.0.0.1, 12.34.56, and lines with no IP at all. If no sample file is provided in your workspace, generating one yourself, manually or with a short script, is part of the exercise and will deepen your understanding of the problem. Your script must accomplish the following tasks in order. 1. Accept the input log file name and the output file name either as command line arguments or as hard-coded variables clearly identified at the top of the script. 2. Open and read the log file safely, handling the case where the file does not exist using a proper try/except block. 3. Apply a regular expression with re.findall to extract all candidate IPv4 addresses from the entire file content. 4. Optionally filter out invalid addresses by verifying each octet falls in the range 0 to 255. 5. Deduplicate the list while preserving the order of first appearance. 6. Print a summary to the terminal showing the total number of raw matches found, the number of valid unique IPs, and the list itself. 7. Write the unique valid IPs to the output file, 1 per line. Once your basic script works, you are expected to push it further with at least one of the following enhancements. Count how many times each IP address appears in the log, use a dictionary or collections.counter, sort the output IPs in ascending numerical order rather than alphabetical order, or add a command line flag stats that prints additional statistics, most frequent IPs appearing only once, etc. These extensions are not optional decoration. They assess your ability to combine data structures, lists, dictionaries, with regex, which is the exact integration point between your last two course chapters. Pay close attention to edge cases. A log line may contain more than one IP address. Some IPs may be part of a larger string like a URL, http://10.0.0.1 to 8080/path, and your regex must still capture them correctly without capturing port numbers as part of the IP. Test your script on at least 3 different log samples to verify robustness. Comment your code clearly, explaining your regex pattern choice and any filtering logic. The goal is not just a working script but a readable, maintainable piece of security tooling. You have 3 hours to complete this workshop. Submit your solution, the Python script and the output file generated from sample.log, before the deadline expires. Late submissions will not be evaluated in the automated correction pipeline.